Today we're going to start looking at angle measures compared to the different segments that we have in circles. Now, the two main ones that we're going to be looking at today are called either central angles or inscribed angles. Let's start with our central angles. And excuse me, I need to put the mic on. We're going to start with central angles and how those can compare with going all the way around the circle. So again, for a reference point, if you do a full turn around your entire circle, how many degrees is that again? That's 360 degrees. So no matter the size of your circle, going all the way around would be considered your 360. So what about halfway around? Well, that would be like a half turn, otherwise known as 180 degrees. So keep that in the back of your brain. So let's see here. We have an arc, which is talking about how much of the circle we've kind of traveled through. And it's just a section of that curved part, a section of our circumference of our circle. Okay, and so we're going to refer to all of our arc measures as what angle they compare to. Here we go. So a central angle is, if we take that apart, an angle where its vertex is at the center. So one example would be angle ABC. So he has its angle, the center of that angle is right at the center of the circle. Alrighty, so when we compare that to an arc, we can talk about three different possible kinds of arcs. We can talk about a minor arc, a major arc, or we can go all the way to semicircle. A minor arc would be something like, arc AC. And so if we think about how that compares, so arc AC is this guy here. Well, that's the same thing. If I extended the sides of angle ABC, my central angle, the sides kind of cut off that arc AC, that minor arc. And in fact, when we have a central arc like that, the measure of the arc is always going to be the same as the measure of the central angle it matches up with. So that's actually going to equal the measure of angle ABC. In other words, 84 degrees from that diagram. Okay, a semicircle is always going to go halfway around the circle. So what other thing do you know that actually cuts a circle in half? Well, that's a diameter. So do we have any diameters on our circle? Well, yeah, we have that straight line, that straight segment going between A and E. So the semicircle is going to go halfway through. And the way I'm going to name that semicircle is actually, we're going to name it ADE. And notice too, these two arcs that I've named, a semicircle, still technically an arc. I'm drawing actually a little picture of an arc, looks like a piece of a circle right on top, so I can tell what those letters are meaning. And so if I follow that through segment or arc ADE, A through to D through to E, that goes halfway around my circle. And I needed that extra point to tell me what direction, because I could also go around the other way and say ACE. Both of these technically are semicircles. Okay, so minor arc AC was 84 degrees. An example of a major arc would be, let's go with ACD. So follow those along and see which part that's looking at. So A going around to C, going all the way around to D, I'm going past halfway around the circle. So a major arc is always going to take up more than half the circle, or more than a semicircle, or more than 180 degrees. And then again, if we go all the way around the circle, it's like doing what degree turn? Well, it's doing like a perfect 360 degree turn. And so the sum of all arcs, if we travel all the way around, we reference the degree that we traveled, which is 360 degrees. So let's go ahead and do some labeling on here. So this is the first piece that we're looking at, just comparing central angles with their arc measures that they match up with. Okay, example one. Find the angle measure or stated value. So we're going to go back and forth between arcs and angles on here. So number one has several arcs and one angle. So let's go ahead and do the angle first. So angle JNM. So if I travel through the points, so JNM, and trace through, I'm looking for this guy. So any ideas? Well, isn't KM, isn't he a diameter? Well, if that's the case, then that goes all the way through half the circle, which means how many degrees? 180 degrees. And so if I think, well, halfway around the circle is 180 degrees, I already know the 21 degrees part, so the leftover, just subtract. So 180 minus 21, well, that gets me 159. So our angle JNM is 159 degrees. And knowing that actually lets me label a whole bunch of other things on the diagram. So let me change my colors. So let's go to red. So let's see, do you see any special angle pairs in here? Again, we're trying to relate angles and arc measures, so anything we know about angles, let's use it if it can help. So do I know anything else that's actually equal to 21 degrees? Well, again, thinking all the way back to the beginning of the year, or the beginning of our semester, back in our building blocks unit, we had vertical angles. So if I know that top angle is 21, then I also know that the bottom angle is 21. And I can do the same thing with 159. So straight across from the N, so angle JNL is also 159 degrees. And that means all of the arc measures kind of match up with those. So again, you don't technically need to label them, but just for ease of mind, that means arc JK would be 21 degrees, and we'd have 159 degrees. From its matching angle, we'd have another 21 degree arc, and we'd have another 159 degree arc. And so let's see what they asked us about. Let's see, arc JK, well, we just labeled that as 21 degrees. Arc KL, we labeled that as 159. Arc JKM. So that's going even further around. So J to K all the way through to M. We'll just add the pieces together. We pass through a 21, a 159, and another 21. So add those together, and we get 201. And then MKL almost goes all the way around the circle, except it skips over that 21. So I'm actually going to do 360 minus 21 to get that one. So 360 minus 21, 339. And that's all I'm doing. I know all the way around the circle is 360, and I'm just figuring out which sections are which. Okay, number 2 looks like it's all about the arcs on this one. So again, any special arc measures that you can pick out, or any angle pairs that you can pick out? Well, we have the 19, so straight across is also going to be 19. We also have that right angle stuck right in here. If I've got this nice straight segment TR, looks like that's a diameter, well, then I can use that to label the rest of things on the top. I know PUR is a 90 degree angle, so take away your 19, gives me 71 degrees. Let's see, what about PUT? PUT, well, that's just the other side made from the diameter, so that's going to be a 90 degree angle. And then I have my remaining SUR. Well, everything else would have to add together with that to make 360, or I could just take the fact that this, again, if this is a diameter and I know the 19, I could also just subtract 19 from 180, which equals 161 degrees. Now, all of our arc measures are exactly the same measures. So again, we could go ahead and label them like we did with the green ones in example 1, but I'm just going to go ahead and match them up directly with the angle measures. So let's see, PQ. Well, that's the same arc that's cutting off the 71 up the top, so that's 71 degrees. SR, well, again, that's SR, still a minor arc, and I know that because it only used 2 letters to name it. But then QRT, so now I'm into the major arcs. So QR all the way around to T. I went past the halfway point plus an extra 19. So 180 plus 19 would give me 199. PSR. So P all the way around SR. I'm taking out that extra section that's 90 degrees. So that means we're left with 270 degrees. And then arc PS. Which direction are we going if it only gave me 2 letters? Whichever one that's going to take me through less than half the circle. So that means I'm going around this way. So I have to put together the 90 and the 19. So we're looking at 109. Yep. Alrighty. So number 3 is kind of an application problem. So here we go. So number 3, it looks like I have 2 things being measured. So I have the arc measure for arc AD, and then I have the arc measure for arc BC. So real quick, look for the angles that match up with those. Let's see here. So the 8x plus 12, well, that's the same arc that's being cut off by this angle AED. What about the BC arc? Well, that's being cut off by this one. Wait a second. Those angles are straight across from each other. So that means those angles are actually vertical angles, which means they have to be equal, which means, what do you think the arcs, how do you think they compare? Well, that means the arcs are equal too. Okay, so let's just set them equal. So 10x minus 22 equals 8x plus 12. And in fact, anytime you see that, if you know that the angles that cut off the arcs are equal, well, then the arcs have to be equal. We saw that with our vertical angles that we looked at in 1 and 2, with the 19 in number 2 and the 21s in number 1. So let's solve that for x and see where it gets us. So let's subtract an 8x from both sides. That gives me a 2x minus 22 on the left. And then add 22 to both sides. So 2x equals a 34. Divide both sides by 2. And just to double check, 34 divided by 2 is 17. Let me make sure, double checking my math. Yep. Alrighty, so x equals 17, that's the first one on the list. But they do want us to find some arc measures. So that means I'm probably going to have to plug the x back in. So let's do that. So let me change my color. So 8x plus 12, if I do 8 times 17 plus 12, gives me 136 plus 12 gives me 148. So that's a 148 degree angle, which means the opposite one should be the same. And plugging that in would actually be a really good way to check our work. So let's see, 10 times 17 would give us 170. 170 minus 22 gets us to that same 148. So that one works. So if I know those are 148, what does that mean we have with our leftover small arcs? How would we find those? Well, again, 2 ways. I know that those 2 pieces, so arc AB and arc DC, those would have to be congruent to each other. So I notice in my list of what they're asking us for, we do have those 2 listed. So once we find one, we find the other. But let's see, couldn't we do this just with a half a circle? Well, sure. So half a circle means those 2, the 148 plus another angle would be 180. So let's just do 180 minus 148. That's an 80, not a 6. So 180 minus 148 gives me 32 degrees. So these are both 32, and now we should be able to answer everything else. So let's see, AD, that's actually the left-hand blue one. So that's 148. Let's color code. That's the one. Oop, that was in red. 148 degrees. And then let's see, CD, he is marked as 32 with the matching angle. And then BDC, again, trace along in order, B around to D, around to C. So I have to put a 32, a 148, and a 32. Put those together, we have 212. All righty. Number 4 looks a little tricky. However, keep in mind, I'm seeing I have measures on every single arc except for this one, VY, And what should his measure be? Well, he's got the 90-degree angle cutting that off, so that should be 90 degrees. So that means we can go ahead and add all of these expressions up, and they should all equal 360. So I'm going to suggest go ahead, pause the video, and I want you to try this one out on your own. Add everything up to 360 and then start labeling everything in as you can. Alrighty, so you may notice, so I found x equals 7, and then I plugged that back into each expression. So I found that arc VW was 56 degrees, arc WX was 135 degrees, arc YX was 79 degrees. And so the only one that I had to do a little bit of math for, or two of these that I had to do some math for, we had arc YW that I had to either add together the 135, and that's a typo. So YW, oh, that is not a typo. YW, again, only 2 letters, so I know that's the minor arc, so I had to add together the 90 plus 56 to get the 146. And then the VXW, again, went kind of long way around. So VXW was everything except for the 56. So this one here was 360 minus that 56.